Hello friends, welcome to my channel. Welcome to Daily Code Challenge. All right, so I'm excited to be here today and also having you around. Welcome to another episode of this series. Let's see what we have for today. Today we have prime factors. It says write a function prime factors that accepts a number as an argument. The function should return an array containing all of the prime numbers that can divide the given number. So what this means is taking line 9 as an instance. Here on line 9, we have 12 as our argument. We want to return every prime factors of 12, right? And how can we achieve that? Firstly, let's list every number between 1 and 12. 1 and 12 inclusive. So let's start with 1, 2, 3, 4, 5, and 12. So here we have numbers 1 through to 12. Okay, so from here, we need to first of all extract the factors of 12, not the prime factors yet, but just the factors of 12. So what are the factors of 12? We know we have 2, we have 3, we have 4, we have 6, right? Now, among these numbers, 2, 3, 4, and 6, which of them are prime numbers? So that gives us the prime factors of 12. So the numbers that are prime numbers among these numbers are 2 and 3. That's why here we have 2 and 3 as the result, right? So here we need to write some code to achieve this, to achieve all what we've just done here, and also for the rest of line 10 to 15. So I am simply going to take this out. Or let me just leave this one for reference sake. Let me take this out and then comment on this. All right, so before we move into this code implementation, we need to first of all understand or know how to write, how to check if a number is a prime number, right? So to achieve that, there's a video I actually made on day 17, and I really encourage and recommend that if you've not watched that video or if you've not been following up this series, do well to go to that video on day 17 to watch how to check for prime number. So here is the function to check if a number is a prime number or not, because we are going to be using this in our code. So if you've not seen this video, please search through the playlist day 17 and then watch it. After you've watched it, you can come back to today's episode and continue with the implementation, right? Okay, so we are simply going to be copying this code here. So I'll just close day 17 and paste this code here. All right, so now we have the code that helps to check if a number is a prime number or not. The next thing we want to do is we want to write this function proper. That's prime factors. So we begin by writing the function keyword and then choose the autocomplete. We remove name, we change it to prime factors, and also we change params to num. So we have num here. We can as well have num here. They don't conflict themselves, right? Because this is a separate function from this function. So the next thing we need to do is we need to look through every number from 0 down to 12. So using the for loop, we say for, I select the autocomplete and I change index to I change array.length to num, and also take out this line of code because we don't need it. Okay, having established this, the next thing we want to do is we want to check for the factors of 12 first, right? So after we've checked for them, then we need to push them to a new array. Okay, so let's first of all, let's see the factors of 12. Let's write the factors of 12 using an if statement, because we want to check if a number can divide 12, 12 being the argument here. So we simply say if then put in the condition. Now, what is the condition we need to put in? We need to check if 12 is divisible by every number from 0 down to 11, because this I equals 0 means we are starting our index from 0, and I less than num, simply we are stopping at 11. So this means we are going to be writing num modulus I equals to 0. So this statement simply means that we want to check any number that divides 12 without a remainder. That's numbers between from 1 to 0, from 1 to 11, sorry. So that's what we want to do. So if any of those numbers exist, we want to push those numbers to a new array. So we name the new array. We say let new array, we call it new array, and we set it to an empty array, right? So let us push every number that can divide 12 without a remainder into that new array. We simply say new array dot push. Now we need to push what? I, because I represents the number, right? So we need to return new array. We return we return new array rather. And then let's save this code and let's run. Okay, so here we have 1, 2, 3, 4, 6. That's for 12. For 7, we have 1. For 16, we have 2. Now, we need to understand that 1, 2, 3, 4, and 6 are factors of 12, correct, right? So the next thing we want to do is we want to check if out of all these numbers, which of them is a prime number, right? So what we need to do is, let's close this console. What we need to do is, in this if statement, we need to add another condition using the AND operator. So we say AND. So of these numbers that divide num without a remainder, we want to check if any one of them is a prime number. So using this function is prime, we are simply going to come here and say is prime, then put I inside of it. So what this means is that we want to check if any of the numbers looping from 0 to 11 can divide 12, and let that number be a prime number. So let's save this code and let's run again. Okay, now you can see that the numbers are reduced. Now we have 1, 2, 3, right? Then we had 1, 2, 3, 4, and 6. Now 4 and 6 are gone because 4 and 6 are not prime numbers, but 1, 2, and 3 are prime numbers. But here, if you look at the output here, we have just 2 and 3. So I believe the program here don't want us to return 1 as part of the prime numbers, right? And because 1 is not a prime number, the first prime number begins with 2. So what we can do here is, because here we started from 0, so it's counted 1 as part of it, because 1 can divide any number without a remainder, right? So that's why 1 is appearing here. So we remove this 0, and rather we don't start from 0, we start from 2, since we understand that 2 is the first prime number that exists in the numeracy, right? So we begin our iteration from 2. So let's save this and let's run again. Okay, so here we have 2, 3, 2, 3 for argument 12. For 7, we have an empty array. For 16, we have 2, which is correct. So we have 5, 2, 3, 5, 5, 7, 7, and 2. So the rest of them are actually correct, except for argument 7. And why is that? It's so because we did include 7. We did include the argument as part of the iteration, right? We stopped at a number before the argument. In this case, we stopped at 6, right? That's for this argument 7. For argument 12, we simply stopped at 11, right? But 11 will not affect the result for 12. But for 7, it affected. So what we can do is to simply include the argument itself by saying I less than num plus 1. Let's try this and see. Okay, so here we have 2, 3, and then we have the 7 here. Or if you don't use 1 plus 1, what I love using is just to say I less than or equal to. So the equal to here, it already includes the argument itself, right? So I am going to save this and then clear this console and then run this code again. Okay, so here now we have all the required output. We have 2, 3 for argument 12. We have 7, 2, 2, 3, 5, 5, 7, 7, and 2, which conforms with this required output. All right, so I am going to take out this series as well. So with this, we've been able to implement the code to find the prime factors of a number, right? So, like I will always say, please try other ways to achieve this because I know there are so many ways to solve a coding challenge. And if you have other ways, please share with us on the comment section. And if this video interests you, please like this video, subscribe to this channel, Dev with Excel, and also turn on your notification, right? Okay, so with this, I say thank you for joining on this call. Have a nice time and bye.